Structure of carboxylic acid. What is the formula of carboxylic acid? RCOOH. Okay. R C double bond OH. Remove one hydrogen from this. Due to its acidic nature, carboxylic acid gives one H plus ion or loses H plus ion to form carboxylate ion. This is called carboxylate ion. Right? See, in carboxylate ion, it is considered this X as the bond length between carbon and a single bond oxygen, and Y is the bond length between carbon and a double bond oxygen. Now, what is the relation between X and Y? Which bond length is greater? Answer to my question. Which bond length is greater? Which bond? X greater than Y. Okay. Right. Correct answer only, na, that is, or any corrections? Any corrections? Answer is X is equal to Y. Answer is X is equal to Y. Due to resonance, in carboxylate ion, resonance takes place. This negative charge participate in the resonance. At that time, this double bond will shift towards oxygen. Okay, to give this resonating structure. So very important point here. This is negative and right. Due to resonance, that to equivalent resonance. The carbon oxygen, two carbon oxygen bond lengths are same. Very important point. This is carbon oxygen. This is also carbon oxygen. Two carbon oxygen bond lengths are same due to equivalent resonance. Two carbon oxygen bond lengths are same in carboxylate ion. Okay, X is equal to Y. And hybridization of the carbon in carboxylic acid or carboxylate ion. Hybridization is sp2. Hybridization of carbon is sp2. This carbonyl carbon oxidation hybridization is sp2. Acidic nature. Carboxylic acids act as acids due to presence of hydrogen on the more electronegative atom. Right. This reaction represents acidic nature of carboxylic acids. Just now I given this equation. Okay. Due to hydrogen present on the more electronegative atom, carboxylic acids, in the name only the term acid is there. Right. They act as acids. Right. Comparison of acidic nature of carboxylic acids. See, in GOC we discussed already. This is called conjugate base. The species which is obtained by removing H plus from the acid is called as conjugate base. This is acid, we removed H plus, the negative part is called as conjugate base. This is termed as conjugate base. The negatively charged species or negative part obtained after separating H plus from the acid is called as conjugate base. Why I am talking about conjugate base? To predict acidic nature of any compound like alcohol or carboxylic acid or phenol or benzoic acid, anything, we have to write conjugate base and we have to identify the stability. We have to compare the stability of the conjugate base. If conjugate base is more stable, the corresponding compound will be more acidic. This is the key point. Sometimes we get theoretical questions also. Clear? Remember, first we have to write the conjugate base by removing H plus from the acid. Take acid, remove H plus, write negative part, that is conjugate base, and observe its stability. Clear? If conjugate base is stable, corresponding compound is more acidic. When conjugate base will be more stable? When it is attaches to minus I group or minus M group. If conjugate base is attaches to minus I or minus M group, then it will be stable. Clear? That's why acidic nature will increase by minus I groups. Minus I, minus M also even. Okay? So write that point. We already discussed these points in the first year. Clear? So I am giving that statement. If conjugate base is stable, then the corresponding compound is more acidic. Corresponding compound is more acidic. Right. When conjugate base is stable, when it is attaches to minus I or minus M groups. Okay, right. Minus I, minus M groups, minus I or minus M groups increase stability of conjugate base. And they increase acidic nature. So this is the key step. You will get some statement type questions. Minus I groups increase acidic nature of carboxylic acid by increasing stability of conjugate base, by decreasing stability of conjugate base, like statement type questions. Minus I groups increase or minus M groups increase stability of carboxylic acids by increasing the stability of conjugate base. They stabilizes the conjugate base and thus increase the acidic nature. Okay, concept based questions. Why acidic nature of carboxylic acids is more when minus I is attached? Because minus I group stabilize the conjugate base. Clear, all of you? Is this point okay? This is first year topic. Again, I'm giving some revision. Got it, all of you? New students, old students can understand easily, no problem. Clear, all of you? Is it okay for you, everybody? New students, right? And one important point, question coming area, Ka, pKa. This is very important. From ionic equilibrium or from the first year GOC, I am giving directly. Ka is directly proportional to acidic nature. Just remember this point or relation. Acid dissociation constant Ka is directly proportional to acidic nature. If Ka value is more for a compound, its acidic nature will be more, right? Based on the Ka values, we can compare the acidic nature. And pKa is inversely proportional to acidic nature. Ka means acid dissociation constant. Ka stands for acid dissociation constant. Acid dissociation constant. pKa means negative logarithm of Ka. pKa is equal to minus log Ka. Negative logarithm of Ka is called pKa. Both are inversely related. If acidic nature is more, pKa is less. If acidic nature is less, pKa is more. Reverse relation. This is direct. Clear? Right. See, before starting the acidic nature questions, I will give you minus I groups, few minus I groups and few minus M groups. Okay. Only few examples I will give you. Minus I groups. What are minus I groups? Electron withdrawing groups. electron withdrawing groups. Electron withdrawing groups. Let us write a few only. Minus NF3 positive, important only. NH3 positive, NO2 cyanide. Actually, in the regular class, I'll give like aldehydes, ketones, carboxylic acids, etc., right? But I'm giving few only. Aldehyde also minus I group, but I'm not giving halogens, fluorine, chlorine, bromine and iodine. After that OR, OH, okay, and a triple bond. Even alkene, phenyl groups also, okay, benzene ring, phenyl. In the regular class, I'll give few more examples also, but these are enough for the acidic nature of carboxylic acids. Clear? Because if I give all, you are unable to remember. All minus I groups are no, not correct. Once look at this. Look at this. OH is there in the minus A order, but what is OH nature? What is OH nature? OH is a plus M group. Which is a plus M. That statement is not always correct. Okay. What I am saying, at least see, to understand the acidic nature of carboxylic acid, remember at least these: NF3, NO2, cyanide, fluorine, chlorine, bromine. At least these. Ticked one. 1, 2, 3, 4, 5. Limited examples. Right. This order is correct only, but I given few examples only. Right. And you know plus I groups. Everyone tell me plus I groups. Plus I groups are electron donating groups. Electron donating groups. Electron donating groups. All alkyl groups. All alkyl groups. All alkyl groups are electron donating groups, like methyl group, and so on. Methyl ethyl. So learn in the same order. NF3 plus is greater than, NO2 greater than, cyanide greater than, halogens. Very easy. Halogens come after NF3, NO2, cyanide. Remember like this: NF3, NO2, cyanide. Order also very important. Order also very important. NO2 and fluorine, which is a strong minus I group. NO2. This idea is very important. Clear? Which is a strong minus I group. NO2 is a strong minus I group. Fluorine is a poor minus I compared to NO2. Compared to NO2. Among all the halogens, fluorine is a strong minus I group. Minus I strength is more, its withdrawing capacity is more. Okay. Right. Shall I clear this? Minus I groups. Next. Keep heading minus M groups. Minus M groups. Electron withdrawing groups. These are also electron withdrawing only. Minus I also electron withdrawing, minus M also electron withdrawing. Minus means withdrawing, plus means donating. Okay, but M means withdrawing through resonance. I means withdrawing through inductive effect. Difference is there. Both are withdrawing only, but one is through resonance, one is through inductive. Minus M is electron withdrawing group through resonance effect, right? Plus M group, donating groups through resonance. Let us write some important minus M groups useful for the acidic nature concept. NO2, cyanide, aldehyde, ketone. Carboxylic acid is also minus M, but we are discussing carboxylic acid only, that's why I am not writing. And you can write ester also. You can write amide also. Ester amide also considered as a minus M groups. C double bond to C double bond to a link is present, then it acts as a minus M, ester and amide, right, as it is. And plus M groups, OH, NH2, OR, NHR, okay. And see, ester also considered as a plus M, but link is different. Amide also, but link is different. Okay, these are electron donating groups through resonance. And one important point, every minus M and every minus plus M also having minus I effect. Minus I, exceptional cases are there, leave them. Minus I is present for all these groups. Minus I is present for all these groups, including their original effect minus M, original effect plus M. So if I ask you what is the effect shown by OH plus M minus I, what is the effect shown by NH2 plus M minus I? That is also important question. What is the effect shown by NO2 minus M minus I? Minus I is common. Minus I is common for these groups. Okay, right. Let us start. Minus I minus M groups increase acidic nature. This is the relation. Increase acidic nature of carboxylic acids. Carboxylic acids, alcohols, every functional group which act as an acid. Okay. This is a relation, general relation, very important relation. Okay, let us start the examples. Right. What about plus I plus M groups? Opposite. Plus I plus M groups? Plus I plus M groups. They decrease the acidic nature. Opposite statement. Okay, right. We will cover NCERT examples also. This is NCERT example only. Formic acid, acetic acid, fluoroacetic acid. Names also important. Yesterday I given the names. Formic acid, acetic acid and fluoroacetic acid. First we have to check minus I group, because minus I minus M groups increase acidic nature. Okay, locate where minus I is present and where plus I is present. Right. CH3. What is CH3 nature? CH3 is which group? C. Plus I group. Just see, don't consider this COH. Put COH in a box. Okay. Just observe the nature of the groups or atoms attached to COH. Put COH in a box. Put COH in a box. Right. Here plus I group is present. Methyl group, all alkyl groups are plus I groups. Okay, next this is minus I, CH2F. Fluorine is a strong withdrawing group. Minus I group, plus I minus I. And what about hydrogen? Hydrogen is neutral. Hydrogen is neutral. Zero inductive effect shown by which group? Hydrogen. Which atom? Hydrogen atom. Right? Okay. And let us give Ka values also within the bracket. Ka1, Ka2 and Ka3. Ka3. Right. First of all, acidic nature order. Acidic nature order. Acidic nature. Right. According to the statement, minus I minus M groups increase acidic nature. Here minus I is present. Okay, so C is more acidic. After that A, because A is neutral. In B plus I is present, that is less acidic. Clear? First minus I, acid with minus I. Okay, next neutral A. After that plus I, this is least acidic. Acetic acid is least acidic. Acidic nature order, right? Next Ka order, same. Ka order depends on acidic nature only, na? Which is more acidic? Option C. So Ka3 is greater than Ka1. Ka1 is greater than Ka2. Clear? Sometimes we will get question in terms of Ka. Which of the following has more Ka value? Or arrange the following compounds in the increasing order of their Ka values, pKa values. What about pKa? pKa order is reverse, right? Can I write pKa order like this? pKa3 is less than, pKa1 is less than pKa2. Just reverse the order, Ka order, then you will get pKa order. If you get pKa question, first write Ka order, then reverse it. That will be the pKa order. Okay? Right. Any doubt in this question? Is there any doubt in this question? Shall I clear this first question? Okay. Right. Second one. Can you guess? Anybody? See, I include AdCb. Yes. See, inorganic acid HCl, H2SO4, these are stronger acids. These are because of complete ionization, 100% ionization. They act as strong acids, inorganic acids. Okay. HCl is more acidic. Even it is having minus I, but this is organic acid. Inorganic acids are stronger acids compared to organic acids. A greater than D. Why D? Minus I group is present. After that C. There is no plus I. Last B, because plus I is present. Just now I given one example. CH there is a plus I, it decreases acidic nature. Clear? Right. Answer will be A greater than, D greater than, C greater than B. Okay. See first question. Which is more acidic in first? CBA. C greater than, B greater than A. See, CAB. No, C greater than, B greater than A. Once look at this, all of you, CAB. Array. This is not benzene ring. This is cyclohexane only. I didn't give benzene. I didn't start benzene example. Benzoic acid and derivatives. Just I am covering aliphatic only. This is not benzene ring. Don't consider ortho, meta, para positions. Clear? This is just aliphatic category only. Clear? This is not benzene ring. Give the positions 1, 2, 3, 4, 5, 6. New students, see. First I am giving the positions 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. See the position of the minus I. Here minus I is closer to the COH. Here minus I is a bit away. Minus I is far. Right? If minus I is present closer, then the compound will be more acidic, because for acidic nature minus I groups should be present. All are having minus I groups only, but in which minus I is very closer? In C. So C greater than B greater than A. A is least acidic. Why A is least acidic? Because in A minus I group is away from the COOH. Got it? Right. New students, did you get this? Yes. Applicable to benzene and derivatives, benzoic acid and derivatives. Even ortho effect also. Okay, this is aliphatic case now, so don't consider them like meta position or the effect case. Just ignore them. Right. Next, second one also. Yeah. 1, 2, 3. Third position minus I. 1, 2, 3. Third position also minus I, but different minus I groups. If two minus I groups are present, then check which is a stronger minus I. Just now I given the order now, NO2 greater than fluorine. NO2 is a stronger minus I group, so its acidic nature will be more. If two minus I groups are present in the same position, see 1, 2, 3 third position, 1, 2, 3 third position, then check the strength, which is having more minus I strength. Once look at this. Fluorine is having more, NO2 is having more minus I strength. NO2 greater than cyanide greater than fluorine. NO2 is a strong minus I. NO2 is stronger minus I. Than fluorine. So B greater than A. B greater than A. Right. Here same concept. B greater than A greater than C. Fluorine greater than chlorine greater than bromine greater than iodine, minus I order. Fluorine is a strong minus I group. After that chlorine, so B greater than A greater than C. Next. Sorry, D. Yeah, DCBA. See, for new students, I will give you an order to you. Carboxylic acids are more acidic than generalization. Carboxylic acids are more acidic than phenol. Phenol is more acidic than water. Water is more acidic than alcohol. This is general order. Even you can add formic acid also. Formic acid is more than RCO. Formic acid also carboxylic acid only. Formic acid, carboxylic acids, phenol, water and alcohol. In the middle benzoic acid also will come. I will give in the resonance. Just learn this. In inductive learn this. In the resonance I will add some other example also. Formic acid substituted carboxylic acid like acetic acid, or means any carbon chain. Phenol greater than, water greater than alcohol, by heart. Formic acid substituted carboxylic acid, phenol, water, alcohol. Based on this order, overall acidic nature order, which is more acidic. First, C and D are carboxylic acids, but in D minus I group is present, chlorine. So D greater than, C greater than. DC is over. Next, water and alcohol. Water is more acidic. So B greater than E. Comparison of acidic nature of different functional groups. This is also important question. Okay. Carboxylic acids are more acidic remaining than other compounds, remaining compounds. Why? What is the reason? What is the reason? Tell me. Why carboxylic acids are placed first here? Due to equivalent resonance. Right. Next, let us start benzoic acid and its derivatives acidic nature. Right. benzoic acid. Benzoic acid and derivatives acidic nature. Benzoic acid formula C6H5COOH. C6H5COOH, benzoic acid. Write one statement: minus M groups increase acidic nature. Minus M groups increase acidic nature. Plus M groups decrease acidic nature. Plus M groups decrease acidic nature. And before starting the examples, I'll give you one phenomenon, that is Ordo effect. Ordo effect. Look at this. Ordo effect. This is benzoic acid, simple benzoic acid. This is substituted benzoic acid. Substitution in the para position, substitution in the ortho position. Substitution in the ortho position. This is ortho substituted benzoic acid. This is para substituted benzoic acid. In para position, minus M group is present. In ortho position, minus M group is present. Whatever it may be the nature of the group, whether it is plus M or minus M, if any group, irrespective of its nature, minus M plus M, if present in the ortho position, then that acid will be more acidic. That carboxylic acid will be more acidic than the remaining. That is only ortho effect. The ortho substituted benzoic acid is stronger acid than the remaining. The ortho substituted benzoic acid means in ortho position, if any substituent, plus M, minus M, if any substituent is present in ortho position, that will be more acidic than remaining isomers. Clear? The reason is not important for NEET level. Clear? That will be important for JEE mains. Clear? What is the reason? For you, reason is not important. Just if you compare the acidic nature, that is enough. So don't think about the reason. Clear? Right. First of all, write the phenomenon or definition. Ortho substituted benzoic acid. Ortho substituted benzoic acid. Benzoic acid is stronger acid. Than remaining isomers. Than remaining isomers. This is called as ortho effect. Ortho effect. Ortho substituted benzoic acid is stronger acid than its remaining isomers. We will do the examples. First of all, concept is clear. Ortho effect concept for everyone. Okay. Let us start the example. So, according to our statement, this will be more acidic, right? Don't write. I'll give examples only. This will be more acidic because this is ortho substituted benzoic acid. Remember the two statements and this phenomenon, ortho effect. Okay. Let us start the examples. Right. And one more point. I'll give you overall acidic nature. Just now I given one overall acidic nature, then another overall acidic nature order. Note down this also. Formic acid is more acidic than benzoic acid because based on the resonance. Benzoic acid, aliphatic carboxylic acid, phenol, very important order, and water after alcohol after alkynes. Alkynes also act as acids. Then alkenes and alkanes, least acidic order. alkenes. This is overall. First box is important. Remaining optional only. Alcohols are more acidic than alkyne. Alkyne is more acidic than alkene. Alkene is more acidic than alkane. But this box is important, right? This is optional. Alkanes, alkenes, alkanes. Order is optional, but examples in the box are important. Formic acid is more acidic than all others without a substituents. Plain. If you take plain examples, then formic acid will be more acidic. Clear? If I attach any minus I, then order will change. But for this is plain case, plain category. I'll give you one question also to understand this. Actually, we are doing first year GOC revision. All these concepts are in GOC, General Organic Chemistry. Which of the following has more Ka value? More Ka value. Based on this overall acidic nature, I will give you one question to you. What will be the answer? What is the answer? Tell me. Others, online students, please respond. Others. BA. No, one only. Select one only. Which of the following has more Ka value? One option. B. B is benzoic acid, right? C6H5COOH. This is benzoic acid. C6H5COOH. This is phenol. C6H5OH. Phenol. Right. Okay. Shall I clear this? Shall I clear this? Once see this, minus some groups increase acidic nature or the effect case. Let us start very important examples. Right. Example 1. Orthonitrobenzoic acid, metanitrobenzoic acid, paranitrobenzoic acid. In the exam, you will get a formula instead of structure. Oh, you can write like this: ONO2 C6H5 COOH. This is a benzoic acid. Benzoic acid in ortho position NO2. That is the meaning. MNO2 C6H5 COOH means metanitrobenzoic acid. This representation also important. PNO2 paranitro C6H5 COOH. Yeah, so Srijan, tell me what is your answer? C. ACB. ACB. What about others? Others. ACB. See, new students. First of all, we have to write all the effects. All the effects. First, see in ortho position substituent is present. In first option, in ortho position, NO2 is there. Ortho substituted benzoic acid, undoubtedly that will be the more acidic. Write the effects here. Ortho effect is present. Ortho effect. Ortho effect. Ortho substituted benzoic acid is stronger acid. So no doubt A greater than. Remaining B and C. Now B and C, how to compare acidic nature of B and C? Very very important point, old students know already, new students see. If any minus M group or plus M group is present in the meta position, its effect do not works. Its minus M effect do not works. Its plus M effect do not works. So NO2 is, what is NO2? Basically it is a minus M. Write minus M and cut it. Write minus M and cut it. Theoretically minus M is appearing here only, but its do not work. Its effect do not works. So cut minus M. Here minus M is present or not? Yes, minus M is present because NO2 is in para. In para position minus M works. Minus M works. So between these two, this will be more acidic because minus M is present. Minus M groups increase acidic nature. Minus M groups increase acidic nature. Here minus M is not present. Why? Because NO2 is in meta. If any group like plus M, minus M is present in meta, it do not works. Clear? Right. So A greater than C, C greater than B. A is more acidic because ortho effect will dominate. That is important point. Ortho substituted benzoic acid will be stronger acid. So ortho effect will dominate remaining other effects. Ortho effect minus M is present, no minus M. That's why it is least. Okay. Completed? All of you completed or not? Next, second example. Take second example. Orthotolic acid. Orthotolic acid. Metatolic acid. Metatolic acid and paratolic acid. First of all, write the effects. Ortho effect is present or not? Yes, because in ortho position substituent is there, CH3, ortho effect. So A greater than B and C, no doubt. Ortho substituted benzoic acid is stronger acid. Next, problem with B and C only. What is the nature of CH3? Yeah, tell me, Adima. A, B, C. Right. What is the nature of CH3? CH3 is a electron donating group, but through which effect? Through hyperconjugation. So I am writing plus H. Hyperconjugation. Donation only. But here hyperconjugation is not present because CH3 is in meta position. Donation effect is absent. You can consider this as a plus M also to understand the concept. Okay. Donation through plus H plus M, both are same only, right? But you know, minus I minus M only increase the acidic nature. Clear? Not plus M plus I. If plus M plus I is present, then what happens? Plus M plus I decreases, acidic nature decreases. Donation is there here, acidic nature is less. For the acidic nature, minus I minus M should present, they only increase the acidic nature, not plus M plus I. If plus M plus I is present, then acidic nature decreases. Clear? Don't get any confusion, new students especially. Minus M minus I increase the acidic nature. Plus M plus I decrease the acidic nature. Here plus M is present, so it is less acidic. Here plus M is absent. Why? Because the group is in meta. Its donation absent. Donation power is absent. Right? So A after C. C or B, sorry. A after B. B after C. A is more acidic due to ortho effect. After that, B is more acidic because there is no donation. Why there is no donation? Because group is in meta position. Donation should not present for the acidic nature. Clear? Here donation is present, plus M is present. That's why this is least acidic. That is the difference between minus M plus M. Opposite, completely opposite. Right? Minus M increase, plus M decrease. Plus M is present, so less acidic. right? Next, shall I clear this? Sorry. What's EBA? Ortho effect. Ortho effect will dominate now. Ortho substituted benzoic acid is stronger than remaining. What is this statement? See, what is ortho effect? Ortho substituted benzoic acid is stronger than the remaining isomers. Ortho effect will dominate. No. Whatever it may be the group, irrespective of the nature, whether it is plus M or minus M, I mentioned already. Ortho substituted benzoic acid is stronger acid, irrespective of the nature. Clear? In ortho position, if you observe any substituent, that will be more acidic, whether it is plus M or minus M group. Right? First give priority for ortho effect. After that minus M plus M. Okay, clear now? Orthotolic acid is a stronger acid because of ortho effect. Ortho effect. Example 3. First of all, you tell me, these are same only, no? Benzoic acid, benzoic acid, benzoic acid. This is phenol. Let us see the overall acidic nature. In overall acidic nature, which will be more acidic in that order, overall order? What I given in the last case? Benzoic acid only, no? No doubt, benzoic acid only. So benzoic acid will be more acidic than phenol. That is based on the overall acidic nature. Now observe. Let us compare. This is very tough question. A, B, C, D, acidic nature order. Can you try? C, D, B, A. How many of you? C, A, B, D. C greater than, A greater than, B greater than D. This is the correct answer. Just now I given to you. Check the overall acidic nature. Overall acidic nature. Once look at this. Benzoic acid is more acidic than phenol. Okay, observe this order. Benzoic acid is more acidic than phenol. Even though phenol is having minus M, it is a functional group. Its acidic nature is less than benzoic acid always, even though it is having some minus M groups. Okay, most of the students will think like this. Here minus M is present, that's why it will be more acidic than this compound. That is wrong, absolutely. See the original functional group. Close this. This is phenol class, this is benzoic acid class. Clear? Even minus M is present, its acidic nature little bit only more than the benzoic acid. Clear? Don't put this in the first step. Clear? Very, very important. That's why I intentionally given this example. Even though it is having minus M, but this is a phenol. Phenol is always less acidic than benzoic acid. Due to equivalent resonance, benzoic acid will be more acidic. Clear? Even though it is having plus M. Even though it is having minus M, this only the more acidic, because observe, this is COOH, equivalent resonance will dominate. Clear? First, by seeing these examples, okay, NO2 is there, this will be more acidic than this. That is a wrong concept, right? Okay. See, in overall order, phenols are always less acidic than benzoic acid. Even though it is having minus M, nothing will affect, right? Note down first, minus M, neutral, there is no plus M, minus M. This is plus M effect, C greater than A because neutral. After that B because plus M groups decrease acidic nature. Last phenols are less acidic now. Very important example. We'll get confusion with the minus M groups, but see, phenol, this is phenol derivative. Phenols are weak acids, right? Clear, all of you? This is easy only, but we may get confusion with NO2 attached to phenol, right? Next example. What is the name of this compound? First compound name, phthalic acid and terephthalic acid. Which is more acidic? Remove hydrogen from any one of the COOH. You can observe ortho effect also. Based on ortho effect, you can say, and another factor also there here. You can say directly, sir, both are ortho to each other, so ortho effect is present. Ortho substituted benzoic acid is stronger acid, and one more important concept also there. Yes. See, let us consider the COOH is losing hydrogen, H plus, and write this as it is. C double bond O H. Hydrogen bonding, intramolecular hydrogen bonding in phthalic acid. So this is also another reason for its more acidic nature. Due to intramolecular hydrogen bonding, conjugate base will become stable. That's it, will be more acidic. Another factor is ortho effect. So A greater than B. A is more acidic than B. Phthalic acid is more acidic than terephthalic acid. Okay. Intra. Within the molecule. Completed? Last example under acidic nature. Malic acid, fumaric acid, important. Malic acid. Yesterday I given about malic acid and fumaric acid structures, right? In malic acid, two COH groups are present in same side or not? Same M malic acid, I given the code also. Fumaric acid, two COH groups are present in opposite directions to the double bond. Which is more acidic? Fumaric acid, malic acid, which is more acidic, which is having more Ka value? That is the question. Which is having more Ka value? In the last case, ortho effect category, that is over. Ortho effect is over. In this case, how to compare acidic nature? Remove proton and observe the stability of the conjugate base. Remove proton from any one of the COOH group. C double bond O negative. Assume one H is coming from this COH as a H plus. So minus H plus, COO negative. Next, write this as it is, C double bond O H. The COH is expanded. C double bond OH. Between these two, hydrogen bonding is present. Hydrogen bonding. Intramolecular hydrogen bonding. The conjugate base is stabilized by intramolecular hydrogen bonding. This conjugate base is stable, so corresponding compound will be more acidic. You will get the question: malic acid is stronger acid than fumaric acid. In malic acid, conjugate base is stabilized by intramolecular hydrogen bonding. Both assertion and reason are correct. Like that type of questions you will get. Clear? More acidic, more stable conjugate base, more stable due to hydrogen bonding. Conjugate base formed from fumaric acid is less stable because there is no hydrogen bonding. Why hydrogen bonding is not formed? Because one COH is present this side, another COH is present this side. So both are opposite, so hydrogen bonding is not possible. Here both are same side only, so hydrogen bonding is possible. Adjacent. When groups are present adjacent, then only hydrogen bonding is possible. When groups are in opposite, hydrogen bonding is not possible. Here conjugate base is formed, but that is not stable when compared with the conjugate base of malic acid. Right. That's why this will be more acidic. A greater than B. Okay. Other students, please respond, all of you. Clear? No one is responding.